Okay, so this is for the systems to test review. All right, so it says for number 1, Sandy wants to solve the system of linear equations 3x plus y equals 17 and 2x plus 4y equals 28 by using linear combination. What should she multiply the first equation by if she wants to eliminate the y terms? All right, so this would be my top equation, right? So looking at my bottom one, I have what for my y term? A 4y, but it's a positive 4y, right? Right, so that means I would have to multiply this whole thing by negative 4 in order for this to be the negative 4 for it to zero out. So therefore my answer is B. You ready for the next one? Yeah? Okay. All right, so number 2. It says, what should we multiply the first equation by if we want to eliminate the x term in this system of linear equations? So, I have what? 3x here on this bottom one, right? So what would I need up here on this top one in order for it to zero out? Negative 3. So, multiply by negative 3 for top equation. And what's our reason? So right. Because it will zero out. Very good, Morgan. You are. Aaron?
What?
Okay, you're ready for number 3? I'm going to move this thing down here. Okay. It says Mary is solving the system 7x minus y equals 10 and 5x plus y equals 24 by linear combination. Which equation shows the result of combining the two equations? Okay, so what does it mean to combine? To add them, right? Okay, so it's like I'm going to take both of these equations and add them together. Which ones are going to zero out? The y terms, right? Because I have a negative y and a plus y. So now when I add the rest of this, what's 7x plus 5x? 12x, right? And that's going to equal, what's 10 plus 24? 34. So now that I have them combined, this would be my answer, right? So it's going to be C. All right, are we ready for the next one? Okay, so on these next ones, we have to determine which method would be the most efficient for solving each system below. And we want to give a reason why. So for A, I have x minus 3y equals 6 and then x minus 3y equals negative 3. Do y'all notice how both of my equations are in standard form? Yeah. So that means I would use which method? Linear combination, LC. And the reason being because both equations are in standard form. And I'm going to just put SF for standard form because I'm lazy. All right, y'all ready for the next one? Okay, so B, I have y equals 2x and then 4x plus 3y equals 30. So I have one solved, right, for y, and then one standard form. So that's right, we are going to use the substitution method, and the reason being because one is already solved for, right? One variable is already solved for, so solved for y. So tomorrow, whenever you're taking the test and it's telling you, you know, like, because I think on some of those questions where you're having to identify which method you're going to use, it wants you to justify your answer, like, or show some type of work. And all you need to do is, like, for this, you would say, well, one's already solved for y. Like, that would be your reasoning. That would be your way to justify it. Does that make sense? Yeah, or like if you had one like this, it would be because both equations are in standard form. I'm going to turn the video over there. Like. All right, C. I have x plus 2y equals 4 and 4x plus 5y equals negative 20. My equations are both in what? Standard form. So that means I'm using what? Linear combination, or LC. What's another name for linear combination? Elimination. Because it's going to refer to both of them on the test. Okay, y'all ready for D? Okay, so I have x equals y plus 4, and then 2x minus 5y equals 2. So, substitution, and the reason is? Alright, so 1 already solved for x. Or you could just put solve for x, whatever. I don't care. What were you gonna ask? Okay. Alright, let's go to E. So here's my two equations, 2x plus 5y equals 14 and 7x minus 5y equals negative 41. They're both in standard, so we have standard form. So that means we're using what? LC. Linear combination. Alright, so then for F, I have y equals 2x minus 5 and y equals 2x plus 10. Graphing is going to be my method because both solve for y, right? Or you could say both are in that slope-intercept form. Can we use our actual calculator to find the point of intersection here?
Is it fine like both have slope-intercept?
Yeah. Yeah. Both are slope-intercept form? That's exactly, I mean, it's the same thing. Awesome. Okay, can we flip over or go to the next page? Did you get it? Yeah. Okay, number 5. Which of the following is equivalent to the system shown below? So both of these are in what form? Standard. And then what do you notice about all of our answer options? They're all in slope-intercept form. So that means I'm going to have to take these two equations up here in standard form and convert them to slope-intercept form to see which one they're equivalent to. Because equivalent means what? Equal, the same, right? Okay, so with this 2x plus y equals negative 10. So to convert this to the standard form, we first have to add or subtract our x term to move it to the other side because our goal is to get y by itself. So that's right. So here I'm going to subtract 2x from both sides. So this is going to zero out. And then I get y equals negative 2x minus 10. Do I need to do anything else? No, because y is by itself now. So let's see what we can get rid of. I know that this one's not going to work, right? Because see how both of these are positive, but in my equation over here, both of them are negative, right? So we can go ahead and scratch out C. Now, if we look at D, this one's a possible answer, right? Because their equation's set up just like mine. What about for B? Yeah, and A, right? So we were only able to eliminate C. Okay. So now let's do the 2x plus 3y equals 15. All right, again, my goal is to get y by itself, right? So what am I going to do? I got to move that x term. I'm going to subtract it so I can zero it out on this side and move it to the other side. So that gives me 3y equals negative 2x plus 15. And now I need to divide by everything by what's ever in front of y, right? So I can get y by itself. So I'm going to divide everything by 3. So then I get y equals negative 2 over 3x plus 5. It most definitely can't be D, right? Because they have it flipped, yeah. And then this one doesn't even have the 3 underneath it, right? So we know it's not B. There was a typo on this. This was actually supposed to be plus 5. So our answer is A.
Oh, I thought I had it wrong.
Nope.
I'm so smart.
You are so smart. Okay, number 6. Which two lines from the graph below form a system whose solution is negative 3, negative 3? So when I'm on the x-axis, which way do I go for negatives? On the x-axis. Do I go to the right or to the left?
Left.
Left. So I'm going over, or I'm going to the left 3 points, right? And then for negative 3 on the y value, am I going up or down? What am I doing? I'm going down. So 1, 2, 3. All right, so look, that's for line Q and line S. So my answer is B. Please don't miss that one tomorrow. It's super easy, right? All right. Are we ready for number 7? Okay. Number 7 says a door-to-door sales person sells dictionaries at $15 each and almanacs at $6 each. Sales over 3 days amounted to 36 books sold, with total sales amounting to $360. So then it says let D equal the number of dictionaries sold and A equal the number of almanacs sold. And we have to write a systems of equation which could be used to find the number of dictionaries and almanacs sold. Okay, so do you notice like this one and this one and this one all have dollar signs in them, right? So that means they are all going to be used in one equation. Okay? So if it's telling me that the almanacs were sold for $6 each, and A represents the number of almanacs sold, I would have to say 6 times what? A. And then I'm going to be adding the other part, right? The $15 for the dictionaries, right? So I would be saying 15 times what? D. So it would be plus 15D. And that has to equal what? 360. So you see how all those pieces go together in one equation? All right. So we know that we have this total, right, of 36 books that were sold. And it was 36 what? What type of books? Almanacs and dictionaries. So what am I adding up together to get to equal 36?
15,
What is it? A plus D, because that's the number of almanacs plus the number of dictionaries that was equal to 36. Does that make sense to y'all? Okay. Are y'all ready for the next one? Number 9. All right, so we have to solve the next two systems by using the linear combination. Okay, so if you'll look right over here on the wall, you'll see that I have the linear combination elimination like process, the steps. So the first thing we have to do is line up our like terms, right? X with X, Y with Y. Are they lined up? Yes. Now I need to find a 0 pair or create one. Do I have a 0 pair? What is my 0 pair? My Y terms. So now I'm ready to combine them. So this zero's out, right? So now I'm going to say 3x plus 2x gives me what? 5x equals 8 plus 7. 15. A lot of mistakes that I'm seeing is like we're forgetting to actually add the two equations together. But when we're doing linear combination, it's really important that we do that, okay? Because if you don't do it, you're not going to get the answer right. So now to solve for x, I just need to do what? Divide everything by 5. So I get that x equals 3. Okay, so now I need to use either one of my equations to now solve for y. So I want to use this one because my y value is positive, okay? And that way I don't have to deal with the negative. So I'm going to take this 2x plus y equals 7, and I'm going to replace this x with what?
3.
With 3. So it's going to be 2 times 3 plus y equals 7. What's 2 times 3? 6. So that's 6 plus y equals 7. And now I need to isolate this variable. That's right. I want to subtract 6 from both sides. So y equals 1. Okay, and now I just want to make sure that my solution is correct, that I have the right numbers. So I'm going to now use my other equation, this 3x minus y equals 8. But for x, what am I putting in there for it?
1.
3, right? So 3 times 3, right? Minus, and what is y going to be replaced with? 1 equals 8. So now I need to distribute this 3 to the 3 inside the parentheses. So 3 times 3 gives me 9. And then it's just going to become minus 1 equals 8. And 9 minus 1 is 8, right? So that checks out. Therefore, my solution is 3, 1. And remember, you have to put x before y on your points. there so we don't get mixed up. Okay, so number 10, same method, linear combination. So are my like terms like lined up? X with X, Y with Y? Yeah? Okay. Now, do I have a zero pair?
No.
No, I need to create a zero pair. Now, we can eliminate any ones that we want, but if we want to do it the easier way, you have to think there's nothing I can multiply to 3 to get to 2, and there's nothing that I can multiply to 2 to get to 3. So I don't want to use that one. But I can eliminate Y because this has a positive 3, right? And I can multiply this whole thing by what to get a negative 3Y here? Negative 3. Because that's what I need to have the zero pair, right? So I'm going to distribute this to everything inside my parentheses, and that gives me negative 9x minus 3y equals negative 15. Okay? And I'm going to go ahead and rewrite my other equation down here below it so I don't get mixed up. If you don't want to do that, you don't have to. All right, so which one am I zeroing out? Right, my y terms. So now I can combine them. So negative 9x plus 2x gives me negative 7x. And that equals negative 15 plus 8, which is negative 7. And now what do I do to solve for x?
Negative.
Very good. I'm going to divide everything by negative 7. So I get that x equals, not negative, because look, I have 2 negatives, right? So it's going to be 1. Did you leave out the negative? Or you put negative with it? Yeah. If you're not ever sure, just put it in your calculator just to check. Okay, so now I'm going to use this top equation up here to solve for y since I have x. Huh? What'd you say? Oh, I thought he was talking to me. All right, so I'm going to replace x with what? 1. So I'm going to have 2 times 1 plus 3y equals 8. So 2 times 1 is just 2. So we now have just the 2 plus 3y equals 8. And now I need to isolate this 3y. So I do what?
Subtract by both sides.
Yeah, I'm going to subtract 2 on both sides. So this zeroes out, and I get 3y equals 6.
Divided by 3.
I'm going to divide everything by 3,
2.
and then y equals 2. And now I'm going to use the equation that was on the bottom to check it. So the 3x plus y equals 5. So x, again, is going to be replaced with what? 1. And y is being replaced with 2. 3 times 1 is just 3 plus 2. And 3 plus 2 is what? 5. So that checks out. So therefore my solution is 1, 2. Are y'all ready to do that tomorrow?
Well, I think yeah.
And just remember, if you get stuck, you can use the anchor chart. Please use the anchor chart. Okay. So now it's telling us to use the situation below for number 11 and number 12. So it says, last month, Christy borrowed $75 from her friend and planned to repay him $5 each week. You see how it says each week there? Automatically, we know that what's going to be attached to this 5? X. And X is going to represent what? The number of weeks. Okay, and then it says Christine earned $10 each week babysitting her little sister. So again, since it says 10 each, that means 10 is going to have what attached to it? X. And then X is again going to represent the number of weeks. So when I write it all out, I know it would be Y equals, right? Because Y is going to be my total, my dollar amount, correct? All right. So she's starting with what in this top part? 75. Because that's what she borrowed. But she's having to, like, repay her friend, right? So am I going to add the 2x or subtract it? I'm subtracting it. Very good. So one equation is going to be 75 minus 2x, or y equals 75 minus 2x. And then for my other equation, it's going to be y equals what?
5.
Because look, Christine earned $10 each week. So we said our 10 was going to be attached to the x, right? So y equals 10x. Because it didn't give us a dollar amount that it was starting with. It was just talking about how much she was going to earn each week. So when I look down here, which one of these are the correct? This is supposed to be 5. Oops. My bad. So when I look over here, which one is the correct answer?
B.
It is B. Weird that it's mixed up like that. It is B. So I had students that were trying to choose this one right here, 5x minus 75. But please understand that that is not at all the same, right? Do you understand that? Because from here, I'm taking 5x away from 75, correct? In the equation that I wrote. But down here, 75 is being taken away from 5x. So there's a big difference. It has to be exactly as we wrote it. Okay, so it wants to know when will the money he owes and the money he earns be the same. So we're looking for the number of weeks, right? Well, I guess and the money because it's asking for both. So that's where we're going to use our calculator because what method are we going to use? Graphing. Because both equations are set to y equals. So in y1 we're going to put 75 minus 5x. And y2 we are going to put 10x. And then we're going to graph it. Okay, so now I just want to look to see what that point is, right, that they're intersecting at. So I'm just going to hit the second trace, and then 5 for intersect, and I hit enter 3 times. And what does it say? 550. So what that means is at 5 weeks, the money she owes and has earned will be what? How much will it be? $50. Okay, any questions over that? You are good? Okay, so let's flip it over. Okay, number 13 says, given the following system, and it's 2x minus y equals 2 and negative x plus 3y equals 9. What should we multiply to the top equation if we want to eliminate the y term? Well, look, my y value up on the top is already negative, right? And then my value down here is a positive 3y. So I really only need to multiply the top equation with what? A positive 3. If this one was positive, then I would have to most definitely do a negative 3, right? But since it's already negative, I don't have to do that. So it's going to be B. Okay, so for the second part of this problem, they're wanting us to determine the value of x for that system above. So up here, let's go ahead and multiply this whole top equation by 3. So when we distribute the 3 across the parentheses, we get 6x minus 3y equals 6. Because, see how my y value is already negative? Yeah. Okay, so now let's go ahead and write our other equation down here. So line everything up. And we already know our zero pair is going to be the y term. So now when I combine them, I'm going to have 6x plus negative x. So think, what would be like 6 minus 1? 5. So this is going to be 5x. Because it's like you're saying 6x minus 1x since this is negative. Okay, and this is going to equal 6 plus 9 gives me 15. And now to solve for x, I do what? I divide by 5. And I get that x equals 3. So am I done? Yeah, because they only wanted to know what the value of x was. Okay, are you all ready for number 14? Yeah? Okay. All right, so what method are we going to use here? Because we got to find the solution for this system. Well, they're both in standard, so we're going to use what? Linear combination. Okay, so they're already lined up, right? Do I have a zero pair? What are my zero pairs? Very good. It's my x terms. So I'm going to zero this out. So now I have negative 10y plus 6y. Very good. Negative 4y. And that equals 8 plus negative 24, or 8 minus 24. Negative 16. I'm going to rewrite this over here so I have more room to do my work. Okay, so to solve for y, I need to do what? Divide everything by negative 4. So y equals a positive 4, right? Since I'm taking a negative and dividing it by a negative, it's going to be positive. Okay, so we could sit here and like go back to the process of like plugging this back in and determining what x is, but I could possibly use like the elimination process for my answer choices, right? Because if you look, which one is the only one that has a y value of 4? D. So that is my only option right there. Okay? Do we understand that? And if we want to double check, all we have to do is take, let's say, the 4x minus 10y equals 8, and just plug these values in. So I would be saying 4 times 12 minus 10 times 4. And 4 times 12 is what? 48. Minus 10 times 4, which is 40. And 48 minus 40 is 8. So therefore, we have the correct answer. So make sure you guys are looking for those little shortcuts that y'all can take, or like eliminating doing any work that's not necessary. Y'all are killing me. How old are you? That's about how old you are acting. Okay. Up here, number 15. Okay, so we have to find the best estimate for the solution of the system represented on the graph shown. Now, they're not actually intersecting, right? But they both have these arrows, which means they're going to continue on, right? So I want to see which of these points is the closest to this point of intersection, right? So if we go to 6, 4, 6, 4 is right here. Is that close to that point of intersection?
No.
No. What about 6, 6? That's right here. No. So we know it can't be this one, it can't be that one. 7, 7 is right here. That's not on either line, right? So it can't be that one. And then our 8, 5 is about right here, right? Yeah. Which one's the closest? 8, 5. Okay, we ready for 16? Are y'all sure? Because I hear a bunch of giggling over here. All right, so I have to graph this system and then find out what my solution is. So for this first one, what form is it in? It's the, well, we can't use the substitution one because it's telling we have to graph the system. But I see that this one's already in what form? Slope-intercept form. So what is my slope here? 3. And then my y-intercept is -1. So I begin where when I plot my points? -1. I always think about your B, that's where you begin. On your y-axis, you start at -1. And since my slope is 3, that's the same as like 3 over 1, right? So that means I'm going up 3, right 1. So 1, 2, 3. Everybody has this part done? Are y'all ready to go on to this one? Or am I going too fast?
You're fine.
Yeah. Janet, is it okay? Yeah? Okay, now is this one in that slope-intercept form, my second equation? My second equation, is it in slope-intercept form? Is y by itself? No. So right away we know it's not in slope-intercept form. How do I get y by itself? What's going on between 2 and y? It's being multiplied. So I have to do what? I have to divide everything by 2. So then that gives me y equals negative 3x plus 11. So what is my slope? Ooh, negative 3. And then my y-intercept is what? 11. So I'm going to begin where? At 11. So we're just going to guesstimate there that that's 11. And then since my slope this time is negative 3, that means I'm going to be going down 3 and right 1. So now I can already see where they're intersecting, so I'm not going to waste my time plotting out any more points. And what point is that? It's 2 and 5. All right, any questions? Could y'all use the calculator on this one?
No.
Yeah, you can. Just make sure that on the test you actually draw your graph. Okay? All right, last page. Okay, number 17 says, which situation is best represented by the system below? We have y equals 80 minus 5x, and then y equals 70 plus 5x. All right, so A says Skylar is conducting an experiment and has a beaker with 70 milliliters of solution in it, and 5 milliliters evaporates away each day. If it's evaporating away each day, does that mean I would be adding that 5 or subtracting it? Okay, so I have 70 up here, but it's saying plus this 5x, right? So we know right away it can't be A, right? Does that make sense to everybody? All right. Okay, so B says Donovan paid an initial charge of $5 to his CD club, and he pays $80 each month. Did I have a y-intercept of 5 in either one of these equations? No. So is that one even possible? And we know, like, since it says initial fee, right, like, that has to be the y-intercept, correct? It's like our beginning point. All right, so C says Dane has $80 in his checking account, and he withdraws $5 each week. Since this is the part that has the each on it, doesn't that mean that X is attached to it?
Yeah.
Okay, and if it's saying he withdraws that $5 each week, is he adding or subtracting? He would be subtracting. So this one is like saying 80 minus 5x, right? So that part checks out. But now we got to check this other part. So it says his brother has $70 in his savings account, and he deposits $5 each week. So again, since it has this each, we know this has the x. And depositing, are we adding or subtracting? We're adding. So since he started off with 70, and he's adding 5x each week, we know it would be 70 plus 5x. So does that match our systems of equation?
No.
Yes, so it's C. Okay, 18 says, if y equals 10, what would be the value of x in the system of linear equations? So they're already giving me the y value, right? So I'm only looking for what? X. So I am going to use this equation right here to determine what my x value is. So I'm replacing y with what? 10. So I would have 2x plus 10, that equals 20. Okay, so now I need to isolate this 2x. So what do? I subtract 10. So then I get 2x equals 10. And then divide everything by 2 to solve for x, and we get x equals 5. So therefore, A is our answer. That's another easy one. Don't get that one wrong. Okay. 19. It says the freshman class needs a combined total of 216 medium and large t-shirts for field day. The number of medium t-shirts needed is 3 times, so we know we're having 3 times the number of large t-shirts needed. So based on this information, would it be reasonable for the freshman class to order 162 large t-shirts and 54 medium t-shirts? Okay, so if I say 162 plus 54, does that equal 216? It does come out to be 216? I agree with you. Okay, so we know that part checks out. But now I need to know if the medium t-shirts needed is 3 times the number of large t-shirts, right? So I would be saying 3 times 162 or 3 times 54? Well, look, it says, would it be reasonable for, because it has, the medium t-shirts needed is 3 times. So which one is going to be a larger value? Huh? Would the medium t-shirts be a larger value or the large t-shirts be a larger value? But it's saying like the number of medium t-shirts needed is 3 times. You need a larger medium amount, right? And down here, she's saying 162 large and 54 medium. Does that make sense? Why the medium t-shirts is a smaller amount than the large t-shirts? Does that make sense to y'all? So therefore, it would not be reasonable, right? So we know it can't be A and it can't be B because they're both saying yes. Then C says no because the number of medium t-shirts is not 3 times the number of large t-shirts. Is that true? Is that the reason why it's not going to work out? Yes. So it would be C. Because the large t-shirts is not supposed to be 3 times. What? Yeah, the large t-shirts are not supposed to be 3 times the amount of the medium t-shirts. All right, last one. Number 20. One wall inside a shoe store is used to display walking shoes and running shoes. There are 133 pair of shoes in this display, and there are 2.5 times as many pairs of walking shoes as there are running shoes on display. So how many pair of walking shoes and running shoes are on display? So we have to create a system of equations here to represent our situation. So how many total do we have? 133. So really the first thing we need to do is determine what variables we're going to use to represent, because what are we looking for again? Walking shoes and running shoes. We don't know what that is, right? So we need a variable to represent the number of walking shoes and the number of running shoes. What do y'all want to use? Okay. You said X and Y? Okay. I didn't. Or you said R and Y? R and W? Huh? Okay. Can we say X is going to be walking and Y is going to be running? Everybody cool with that? So if I say I take the number of walking shoes and I add them to the number of running shoes, I get how many? 133. Okay, so the next part says there are 2.5 times as many pairs of walking shoes, right, as there are running shoes. How many more shoes do we have? The walking or the running? The walking, right? Because it's saying there are 2.5 as many pairs of walking shoes as there are running shoes. So that means X has to equal what? 2.5 what? Y. Because we have to say 2.5 times the number of running shoes. So which method are we going to use here? Can you vote? Will you open the opening? Can you do... Will you put this back there? Thank you. Substitution, because one of our variables is already solved for, right? So we're going to take this X and we're going to replace it with what? 2.5 times Y. Yeah? Okay. So down over here, I'm going to do 2.5y plus y equals how much? 133. All right. So now I have to go through my steps for solving equations. Do I have anything I need to distribute? Huh? No. Do I have anything to clean up? Like, do I have any like terms I can combine? Yes. I have this 2.5y and this 1y, right? So when I add them together, I get what? 3.5y. That equals 133. Okay, now I do what to solve for y? Divide everything by 3.5. Someone please tell me what that is. 133 divided by 3.5. Okay, so we have 38 what? Walking or running shoes? Running shoes. All right, so let's go through here. This one doesn't even talk about 38, right? Does E talk about 38 anywhere?
No.
Yeah, that can't be a possibility. F says there's 38 pairs of walking shoes and 95 pairs of running shoes. Oh, because it's backwards? Yes. And y'all said no to G because that's not even a part of it, so yeah, it has to be H. All right, so that's it. Are y'all ready?
For what?
The test tomorrow. Milena?